Okay, we're going to introduce radians and the idea of what a radian is and why we might want a different angle unit than degrees. So let's say that we've got some sector of a circle here and we want to know the length of this arc here. If we're using degrees, we'll have to take this angle here, theta, and then we'd say, well, what would the circumference of the full circle be? That would be 2 pi r, and then we'd have to say, well, I only want that proportion of it. So we'd have to say, okay, it's theta out of the 360 degrees that are available. And we do that calculation, and that's going to give us just that arc length. Theta over 360 times the full circumference. And that's fine, but every single time we're basically doing theta times r and then timesing by this constant. That choice of 360 degrees in a circle was completely arbitrary. It could have been 700, 1000, 100, it doesn't matter. It could have been any number. So if we're always going to have to find the arc length, multiply by 2 pi and divide by our arbitrary choice of degrees in a circle, why don't we choose a more appropriate number of degrees to be in a circle? And that's what radians represent. One full turn in radians, so what would be 360 degrees, we just call 2 pi radians. We use letter C rather than R, as you may think would be sensible, because it stands for circle measure. By choosing 2 pi radians to be in a full turn, this formula for arc length becomes 2 pi over 2 pi. 2 pi taking the place of our arbitrary 360 times theta r. The 2 pi's cancel, so our formula for arc length is simply theta times r, your angle in radians times your radius, and that will give you arc length. We can see a similar thing happens if we look at sector area. So if I want the area of this whole sector, ordinarily I would have to do pi r squared times our angle out of 360. Again, just taking that proportion which I want. 360 was our arbitrary choice. If we change that, however, to 2 pi, you can see the pi's now cancel. So our formula for a sector area becomes r squared theta over 2. You may notice that actually we have an integral here. If we integrate with respect to r, we find the area underneath our arc length, and that will be sector area. So we use this idea of radians, where you have 2 pi radians in a full turn, and it just makes all the calculations for arc length, sector areas, etc. much easier to do.